Hey there. Tonight we're diving deep into the ocean's most extraordinary inhabitants, creatures so bizarre, so remarkable, that they'll completely change how you see the world beneath the waves. Do consider tapping or clicking on the thumbs up and subscribe buttons if this sparked a little calm or curiosity. No pressure, only if your finger feels like doing it. Now, let your mind and body relax, and let's explore tonight's topic together. 1. The giant Pacific octopus possesses strength that defies its boneless body. Each of its 8 arms can lift nearly 30 pounds, creating a combined pulling force of over 200 pounds. But strength isn't this creature's only remarkable ability. Every one of those suction cups covering its arms contains sensors that can simultaneously taste and smell whatever they touch, allowing the octopus to explore its environment through chemical detection while maintaining its grip. These capabilities have led to some memorable incidents in aquariums worldwide. According to documentation from the Seattle Aquarium, one particularly clever individual managed an escape that baffled staff for weeks. The octopus squeezed its entire body through a drain pipe barely wider than a baseball, traveling through the plumbing system overnight before staff discovered it, exploring a neighboring tank the next morning. The incident highlighted not just the animal's incredible flexibility. Octopuses can compress through any opening larger than their hard beak, but also their problem-solving intelligence and apparent curiosity about the world beyond their enclosures. 2. Deep in the ocean's twilight zone lives the fangtooth fish, a creature that embodies the phrase, "all teeth and attitude." This small fish, typically measuring just 6 inches long, holds the record for the largest teeth relative to body size of any fish in the ocean. Its fangs are so disproportionately enormous that evolution had to find a creative solution just to let the fish close its mouth. Special sockets have formed in the fangtooth's skull, essentially holes where the lower fangs slide into when the jaw shuts, preventing the teeth from piercing the fish's own brain. According to research from the Monterey Bay Aquarium Research Institute, these fangs serve a crucial purpose in the deep sea's pitch-black waters. When prey is scarce and hunting opportunities are rare, the fangtooth cannot afford to let anything escape. Those oversized teeth act like prison bars, ensuring that once something enters the fish's mouth, it has virtually no chance of swimming back out. The fangtooth may look like a nightmare, but in the unforgiving environment 3,000 feet below the surface, those terrifying teeth mean survival. 3. Sea sponges might look like colorful underwater plants swaying with the current, but appearances can be profoundly deceiving. These silent filter feeders are actually animals, and not just any animals, but some of the most ancient creatures still alive on Earth today. Sea sponges have been filtering ocean water continuously for over 600 million years, making them far older than dinosaurs, older than the first fish, older even than most plant life on land. Their body plan is remarkably simple, yet incredibly effective. Thousands of tiny pores draw water through their bodies, trapping bacteria and organic particles for food while expelling the filtered water back into the ocean. A single sponge can filter thousands of gallons of seawater each day. According to the Smithsonian Institution's marine biology research, this ancient lineage has survived 5 mass extinction events that wiped out countless other species. Their secret lies in that very simplicity. With no organs, no nervous system, and remarkable regenerative abilities, sea sponges adapted to almost any marine environment. They represent a direct link to Earth's earliest complex life, still thriving in modern oceans. 4. The gulper eel takes the concept of big mouth to an extraordinary extreme. This deep sea dweller can inflate its enormous mouth like a balloon, expanding the elastic tissue until its jaw opens wide enough to swallow prey nearly as large as the eel's entire body in a single gulp. Picture a creature barely 3 feet long, somehow engulfing a fish almost the same size. This is the gulper. Eel's signature hunting strategy. That massive, pouch-like jaw works through a hinge mechanism so flexible it seems almost impossible, allowing the mouth to unhinge and expand in ways that would tear apart most other animals. According to NOAA ocean exploration research, this remarkable adaptation actually inspired early submarine bag designs used for collecting deep-sea specimens. Engineers studying the eel's expandable jaw realized they could apply the same principles to create flexible collection systems for underwater research vehicles. The gulper eel spends its life in the deep ocean's pitch darkness, where food is scarce and unpredictable. When a meal does appear, that balloon-like mouth ensures nothing escapes, no matter how large. 5. Feather stars create one of the ocean's most surreal and captivating sights. These creatures typically remain anchored to coral or rock, their dozens of feathery arms waving gently in the current, looking exactly like underwater flowers, swaying in a gentle breeze. But when danger approaches, perhaps a predatory fish or a curious diver getting too close, the feather star suddenly transforms. In an instant, it releases its grip and begins swimming through the water, those same delicate arms now rowing in coordinated waves, propelling the creature away from threat. According to National Geographic marine zoology documentation, watching a feather star swim has been described as witnessing an alien spacecraft take flight or a flower suddenly deciding to fly. The arms move in mesmerizing patterns, creating flowing motions that seem almost hypnotic. These creatures are actually crinoids, relatives of sea stars and sea urchins, with a lineage stretching back over 400 million years. Their ability to both anchor and swim gives them remarkable flexibility in the competitive world of coral reefs, where the difference between staying put and swimming away can mean the difference between life and death. 6. The red-lipped batfish inhabits the waters around the Galapagos Islands and has an appearance so unusual it seems almost comical. It looks like a fish that applied bright red lipstick before leaving home. According to research from the Galapagos Research Center, those distinctive red lips might serve to attract mates, though scientists aren't entirely certain of their exact purpose. What's clear is that this fish strongly prefers walking to swimming. Like its batfish relatives, it uses modified pectoral fins as legs, plodding along the seafloor in an awkward, ungainly gait that makes it look perpetually annoyed about something. The batfish walks across volcanic rock and sand, searching for small fish, shrimp, and mollusks to eat. It has a lure on its head similar to anglerfish, though much less dramatic, which it can extend to attract prey within striking distance. The combination of bright red lips, a grumpy expression, and the preference for walking rather than swimming makes the red-lipped batfish one of the ocean's most distinctively odd-looking creatures. It moves like something that's not quite sure how to be a fish, preferring to waddle along the bottom rather than embrace swimming, all while sporting what might be the ocean's most distinctive lipstick application. 7. The barrel eye fish possesses one of nature's most extraordinary adaptations, a completely transparent skull. Looking at this deep-sea creature is like peering into a living anatomy display, where you can literally see its eyes rotating inside its head through a clear, glass-like dome. Those eyes aren't positioned where you'd expect either. What look like eyes at the front of the fish's face are actually its nostrils. The real eyes are the two bright green orbs visible inside the transparent skull, pointing straight upward to watch for prey and predators in the water column above. According to research from the Monterey Bay Aquarium Research Institute, this arrangement solves a crucial problem for deep-sea hunters. The barrel eye spends most of its time motionless in the water, looking up through its transparent dome to spot the silhouettes of small fish and jellyfish backlit against the faint light filtering down from the surface. When prey appears directly overhead, the fish can rotate those tubular eyes forward to track it during pursuit. The transparent skull protects these sensitive eyes while maintaining perfect visibility in all directions, creating a living periscope perfectly adapted for hunting in the ocean's dimly lit depths. 8. Despite its ominous name, the vampire squid doesn't actually suck blood, though its survival strategy might be even stranger than any vampire legend. This deep-sea cephalopod lives in oxygen-poor waters where most creatures cannot survive, dwelling in a zone so depleted of oxygen that it's practically a marine dead zone. When threatened, the vampire squid performs one of the ocean's most unusual defensive maneuvers. It turns itself completely inside out. According to research from the Scripps Institution of Oceanography, the squid wraps its cloak like webbing around its entire body, pulling its arms over itself until the webbing forms a protective ball with all the soft tissue hidden inside. The outside of this defensive sphere is covered with small, fleshy spines called cirri, making the squid look less like an easy meal and more like something unpleasant to swallow. The creature's dark reddish coloring and those dramatic arm webbing earned it the vampire name, but in reality, it feeds on marine snow, tiny particles of dead plankton and organic debris drifting down from surface waters. The vampire squid represents a gentler kind of hunter, one perfectly adapted to survive in waters too hostile for most predators. 9. Sea otters engage in behavior so endearing it seems almost designed to melt hearts. They hold hands while sleeping. When sea otters rest on the ocean's surface, they often reach out and clasp paws with nearby otters, creating what's known as a raft. This hand-holding isn't just adorable, it's essential survival strategy. Ocean currents are constantly moving, and a sleeping otter could easily drift away from its group, ending up alone in dangerous waters or separated from prime feeding areas. By linking paws, the group stays together throughout their rest period, maintaining safety in numbers. According to documentation from the Monterey Bay Aquarium, mother sea otters take this strategy even further with their pups. They'll wrap their babies in strands of kelp before sleeping, creating a natural anchor that keeps the young otter from floating away while mom dives for food or takes a nap. The kelp acts like a marine baby sling, keeping the pups safe and secure at the surface. These behaviors showcase the sea otter's remarkable adaptation to life in the open ocean, where staying together and staying put can make all the difference between thriving and becoming lost at sea. 10. The hagfish deploys one of the ocean's most effective and genuinely bizarre defense mechanisms. It produces massive quantities of slime in mere seconds when threatened. We're not talking about a little bit of mucus here. According to Noaa Fisheries research, a single threatened hagfish can generate enough slime to fill a large bucket, releasing gallons of the stuff almost instantaneously into the surrounding water. This isn't ordinary slime either. The substance contains special protein threads that expand on contact with seawater, creating a thick, fibrous gel that clogs predator gills and makes the hagfish impossible to bite or swallow. The slime is so effective that it can even clog the engines of curious submarines that accidentally disturb these creatures on the seafloor. Predatory fish that attempt to eat a hagfish quickly find their gills clogged and their mouths full of an expanding, suffocating mass, forcing them to release their prey and retreat. The hagfish itself can escape by literally tying its body into a knot and sliding through its own slime, scraping the substance off as it goes. It's a defense mechanism that's both remarkably effective and utterly unforgettable once witnessed. 11. The Dumbo octopus earns its adorable name from the ear, like fins protruding from its head, which it flaps exactly like the cartoon elephant when swimming through the water. But what's truly remarkable isn't the resemblance to Disney's famous character, it's where this creature lives and how it survives there. According to Noaa's Okeanos Exploration Program, Dumbo octopuses inhabit depths where the pressure would instantly crush a car into a compact cube of metal. We're talking about the deep ocean's abyssal plains, often 7,000 feet down or deeper, where darkness is absolute and the weight of water above creates crushing force. Yet, the Dumbo octopus thrives in this hostile environment despite being only the size of a coffee mug, rarely exceeding 8 inches across. It drifts through the black water, flapping those distinctive ear fins in slow, graceful movements, feeding on snails, worms, and other small creatures found on the seafloor. The octopus's soft body is perfectly adapted to extreme pressure. It has no air-filled spaces that would collapse, and its gelatinous tissues are essentially incompressible. What would kill most surface creatures in seconds is simply home for the Dumbo octopus, one of the deepest living octopuses known to science. 12. The blue dragon sea slug lives life upside down, floating on the ocean's surface with its silvery blue belly exposed to the sky above and its darker back facing the depths below. This reversed coloration isn't accidental. It's camouflage that works from multiple angles, making the slug difficult to spot from both above and below. But the blue dragon's most remarkable trait isn't how it floats, it's what it eats. This tiny slug, rarely longer than an inch, preys on one of the ocean's most dangerous creatures, the Portuguese man-o'-war jellyfish. According to research from the Australian Museum, the blue dragon is somehow immune to the man-o'-war's powerful venom, which can cause excruciating pain and even death in humans. The slug doesn't just eat these venomous jellyfish, it steals their weapons. As the blue dragon digests its prey, it selectively stores the stinging cells in specialized sacs in its own tissue, concentrating the venom and repurposing it for its own defense. This means the blue dragon becomes even more venomous than the creature it consumed, turning borrowed weapons into a more potent defense system. It's biological theft on a microscopic scale, transforming danger into protection. 13. The colossal squid holds an extraordinary record. It possesses the largest eyes of any living creature on Earth. Each eye measures roughly the size of a dinner plate, with some specimens showing eyes nearly 11 inches in diameter. To put that in perspective, imagine looking into an eye almost as wide as a basketball, staring back at you from the darkness. According to research from Te Papa Museum in New Zealand, which houses several preserved colossal squid specimens, these enormous eyes evolved to solve a specific problem of deep-sea survival. In the pitch-black waters where colossal squid hunt, often at depths exceeding 6,000 feet, even the faintest light becomes crucial for survival. Those massive eyes can detect the bioluminescent glow of prey in near total darkness, but more importantly, they can spot the one predator that actively hunts these giant invertebrates, the sperm whale. When a massive whale approaches through dark water, its movements disturb bioluminescent plankton, creating a faint glow that betrays its presence. The colossal squid's dinner plate eyes can detect this subtle illumination from over 400 feet away, giving the squid precious seconds to evade its only real predator in the deep ocean's endless night. 14. The Pacific black dragon possesses skin so incredibly black that it absorbs 99.9% of light that strikes it, making the fish practically invisible in the deep sea. We're talking about one of the darkest naturally occurring materials on Earth, darker than most artificial blacks created in laboratories. According to research from the University of California, San Diego, scientists are actively studying the black dragon's skin structure to develop advanced stealth materials for military and technological applications. The secret lies in the skin's unique architecture. It's covered with specialized pigment containing structures arranged at precise angles and densities that trap light rather than reflecting it. When light hits the black dragon's skin, it enters a maze of pigment cells where it gets absorbed and converted to heat instead of bouncing back. This adaptation solves a crucial survival problem in the deep ocean. Even though black dragons live where sunlight never reaches, many deep-sea creatures produce their own bioluminescent light. A fish that reflects even a tiny amount of that light becomes visible to both predators and prey. The black dragon's ultra-black skin makes it effectively invisible, creating a living shadow that can hunt and hide with equal effectiveness in the permanent darkness of the deep. 15. Flying fish don't just leap above the waves, they genuinely glide through the air with impressive distance and speed. These remarkable fish can soar more than 650 feet above the water's surface, covering distances longer than 2 football fields in a single flight. They can reach air speeds up to 35 miles per hour, faster than most people drive through residential neighborhoods. The fish achieve this by rapidly beating their tail fin while still in contact with the water's surface, building up enough speed to launch themselves airborne. Once free of the ocean, they spread their enlarged pectoral fins wide, creating wings that catch air and extend their flight. According to NOAA Fisheries research, this aerial ability evolved as an escape mechanism from underwater predators like tuna and swordfish. When pursued, the flying fish would rather risk the air than stay in water with a faster predator behind them. Sometimes these flights go wrong in spectacular fashion. Sailors throughout history have reported flying fish crash landing on ship decks, apparently misjudging their trajectory or getting caught by wind gusts. It's an aerial escape strategy that usually works brilliantly, though occasionally ends with the fish flopping on a ship's deck, far from any water. 16. Sea snakes face a challenge that might not be immediately obvious. They're air-breathing reptiles living in salt water, but they still need fresh water to drink. According to research from the University of Florida, sea snakes have evolved to exploit a remarkable phenomenon that occurs after rainfall. When rain falls on the ocean's surface, fresh water, being less dense than salt water, temporarily forms an invisible layer less than half an inch thick, floating on top of the denser seawater below. This freshwater lens exists for only a few hours before waves and currents mix it back into the ocean, but during that brief window, sea snakes come to the surface and drink from this temporary freshwater film. They can detect the presence of this layer somehow, perhaps through taste or some other sensory mechanism, and take advantage of it when available. Between rainfalls, sea snakes can survive on the water content in their prey and by producing extremely concentrated urine to minimize water loss, but they still require these occasional freshwater opportunities to avoid dehydration. It's a delicate survival strategy that depends on weather patterns and the physical properties of water itself, showing how even the most ocean-adapted creatures still carry needs inherited from their terrestrial ancestors. 17. Sea snakes can hold their breath for over 8 hours underwater, making them the undisputed champions of breath holding among reptiles. This extraordinary ability far exceeds what any land snake or even most marine mammals can achieve. The secret lies in a remarkable adaptation. Sea snakes can absorb oxygen directly through their skin while submerged. According to research from the University of Adelaide, roughly 25% of a sea snake's oxygen intake comes not from its lungs, but through cutaneous respiration, essentially breathing through specialized skin tissue. The snake's skin is far more permeable to oxygen than that of terrestrial reptiles, and the large surface area of its body maximizes contact with oxygen-dissolved seawater. This dual respiratory system means sea snakes can stay submerged for extraordinary periods while hunting, resting, or evading predators. They typically surface to breathe air into their lungs, but if circumstances require, perhaps when hiding from a predator or pursuing prey into a coral crevice, they can remain submerged far longer than their lung capacity alone would permit. It's an elegant solution to the challenge of being an air-breathing reptile that spends virtually its entire life underwater, never coming to land except for some species to lay eggs. 18. The giant isopod looks like someone took a common pill bug, those small creatures that roll into balls in gardens, and inflated it to nightmarish proportions, creating a crustacean the size of a football. These deep-sea scavengers can grow over 16 inches long and weigh several pounds, making them the largest members of the isopod family. But their size isn't their most remarkable feature, it's their incredible endurance between meals. According to Smithsonian Ocean Portal documentation, giant isopods can survive for up to 5 years without eating anything at all. Their metabolism is extraordinarily slow, adapted to the deep-sea environment where food is scarce and unpredictable. When whale carcasses, dead fish, or other organic matter drift down to the seafloor, the giant isopods feast, gorging themselves to store as much energy as possible. Then they wait. They can afford to wait months, even years, for the next meal to appear. One captive giant isopod in a Japanese aquarium famously refused all food for 5 years and 3 months before eventually dying, possibly from starvation, but more likely from old age. Its patience taken to an extreme, perfectly suited for life in the deep ocean where meals are rare but worth the wait. 19. The Christmas tree worm looks exactly like its name suggests, a pair of colorful, spiraling plumes that could easily be mistaken for miniature holiday decorations sprouting from coral reefs. These brilliant spirals come in practically every color imaginable. Reds, oranges, yellows, blues, whites, and combinations thereof, creating one of the reef's most visually striking displays. But these aren't decorations or plants. They're the feeding and breathing structures of a tube-dwelling worm living hidden beneath. According to NOAA coral reef studies, those colorful plumes are covered with tiny hair, like structures called radioles, that create a net for capturing microscopic plankton drifting in the current. At the same time, the plumes extract dissolved oxygen from seawater, allowing the worm to breathe. The worm itself lives in a calcium carbonate tube it secretes and embeds in living coral, creating a permanent home. When danger approaches, a predatory fish, a clumsy diver, or even a shadow passing overhead, the worm can retract those colorful plumes in a fraction of a second, disappearing completely into its tube. Then, when the coast is clear, the spirals slowly emerge again, unfurling like holiday decorations being carefully unwrapped and displayed for the reef community to see. 20. The Atlantic horseshoe crab carries liquid more valuable than gold flowing through its ancient body, bright blue blood worth roughly $15,000 per quart. This isn't an exaggeration for dramatic effect. It's the actual market value driven by the blood's unique medical properties. According to research from the Marine Biological Laboratory at Woods Hole, horseshoe crab blood contains special cells called amebocytes that clot when exposed to even tiny amounts of bacterial contamination. Scientists have developed a test using these cells called the Limulus amebocyte lysate test, or LAL test, which is used to verify that every vaccine, every injectable drug, and every medical device that enters the human body is free from dangerous bacterial contamination. Before this discovery, testing for contamination was slow and unreliable. Now, horseshoe crab blood provides results in hours, ensuring the safety of countless medical treatments. The crabs are carefully captured, have some blood drawn in sterile conditions, and are returned to the ocean. Most survive the process. This means that living fossils that have existed largely unchanged for over 400 million years are now playing a crucial role in protecting human health in the 21st century, making their blue blood literally life-saving. 21. The blanket octopus displays one of nature's most extreme examples of sexual size difference. Females can be 10,000 times heavier than males. Again, not 10 times, not 100 times, but 10,000 times larger. A female blanket octopus can reach 6 feet in length and weigh several pounds, while the male of the same species might measure barely an inch long and weigh less than a paperclip. According to Smithsonian Institution research, this dramatic difference exists because males and females have completely different survival strategies. The female's size comes from her remarkable defensive adaptation. She can unfurl a web of skin connecting her arms that stretches nearly 6 feet wide, creating an enormous, colorful blanket that makes her appear much larger to potential predators. This membrane shimmers and flows in the current like a billowing cape, startling predators and creating confusion about the octopus's true size and shape. Males, in contrast, are tiny and short-lived, existing primarily to find a female and reproduce before dying. They're so small they can actually rip off the stinging tentacles of jellyfish and carry them as weapons for defense, something the massive females never need to do. It's sexual dimorphism taken to an almost incomprehensible extreme. 22. The wobbegong shark has earned the nickname carpet shark through both appearance and strategy. Its ornate, heavily patterned skin makes it look remarkably like a decorative rug draped across the seafloor. But this beautiful camouflage serves a deadly purpose. According to the Australian Institute of Marine Science, wobbegongs are ambush predators that spend hours lying perfectly still on reef bottoms, their elaborate patterns blending seamlessly with coral, rock, and sand. Around their mouth, they have elaborate fleshy lobes and tassels that break up their outline even further, making the shark's head look like just another bit of reef debris covered in algae. Fish swimming nearby have no idea they're passing within inches of a predator. Then, when prey ventures close enough, the wobbegong erupts from the bottom in a lightning-fast strike, its wide mouth engulfing the victim before it can react. The attack happens so quickly that prey often has no chance to escape, caught completely by surprise by what they thought was just another patch of seafloor. Some wobbegongs even wiggle their tail tips to lure curious fish closer, essentially fishing for their own meals while lying in wait like a patterned carpet with teeth. 23. The harp sponge looks like an underwater candelabra or an elaborate work of modern art with multiple upright branches rising from a central stem. But this elegant structure exists for a reason that's unusual among sponges. The harp sponge is one of the few carnivorous sponges, actively hunting rather than simply filter feeding. According to research from the Monterey Bay Aquarium Research Institute, which discovered this species in 2012, the branches are covered with tiny hook-like structures that work like natural Velcro. Small crustaceans swimming through the deep sea bump into these branches and find themselves instantly stuck, unable to escape the microscopic hooks. The sponge then slowly envelops the trapped prey in a thin membrane, digesting it over several days before releasing the empty shell. Each branch can capture and digest multiple prey items simultaneously, making the harp sponge look like a delicate sculpture while functioning as an efficient deep-sea predator. It thrives at depths where most prey is mobile rather than floating. So the traditional sponge strategy of sitting still and filtering water wouldn't provide enough food. The harp sponge adapted by becoming an active hunter, creating sticky traps from its own body that few creatures can escape once touched. 24. The flamingo tongue snail appears to wear its shell like a living canvas painted with vivid orange and yellow patterns that look almost fluorescent against coral reefs. But appearances deceive in a fascinating way. That brilliant pattern isn't painted on the shell at all. According to Caribbean coral reef studies, the colors and patterns are actually on the snail's living mantle tissue, the fleshy part of its body that wraps around and covers the shell's exterior. The shell itself is plain, smooth, and cream-colored underneath. The snail essentially wears its colorful tissue like a decorated coat, pulled over a boring shell. This matters because those bright colors serve as a warning. Flamingo tongue snails feed exclusively on toxic soft corals called sea fans, and they sequester those toxins in their own tissue, making themselves poisonous to potential predators. The vivid pattern essentially advertises, "I'm toxic, don't eat me." Fish learn to recognize and avoid these colors, leaving the snail to graze peacefully on its poisonous coral garden. When the snail dies and its Soft tissue decays away. Collectors sometimes find the shells and wonder where all the beautiful color went, not realizing they're looking at the boring underneath that was hidden during the animal's life. 25. The leafy sea dragon drifts through southern Australian waters, looking less like an animal and more like a piece of animated seaweed that somehow decided to swim. Elaborate leaf-shaped appendages protrude from its entire body, not functional fins, but decorative camouflage structures that wave and flutter in the current, perfectly mimicking the kelp and seaweed growing in its habitat. According to the South Australian Museum, this camouflage is so effective that divers can swim within inches of a leafy sea dragon and never spot it, even when looking directly at it. The creature's body sways with water movement, just like real vegetation, completing the illusion. The actual propulsion comes from nearly transparent fins along its back and neck that flutter so rapidly. They're almost invisible, allowing the sea dragon to move forward while maintaining its leafy disguise. These strange and beautiful animals eat tiny crustaceans, sucking them up through elongated snouts like living straws. They're related to seahorses, and like their cousins, the males carry fertilized eggs until they hatch. The elaborate leafy appendages make the sea dragon one of the most successfully camouflaged creatures in the ocean, a master of disguise hiding in plain sight among the swaying kelp forests of southern seas. 26. Some species of crabs have developed a defensive strategy that seems almost like wielding weapons. They attach sea anemones to their claws and use them like living clubs to sting potential predators. According to research published in the Journal of Crustacean Biology, these crabs carefully detach small anemones from rocks and hold them in their claws, positioning them so the stinging tentacles face outward toward any threats. When a predator approaches, the crab waves its anemone-armed claws defensively, the tentacles ready to deliver painful stings to anything that gets too close. It's biological armor and weaponry combined, turning another creature into a defensive tool. The relationship can benefit both parties. The crab gains protection, while the anemone gets transported to new feeding locations and may receive food scraps from the crab's meals. Some species form such strong partnerships that if you remove the anemones from a crab's claws, it will actively search for new ones to replace them, apparently recognizing the defensive value of its living weapons. Other crabs place anemones on their shells for camouflage and protection, essentially decorating themselves with stinging bodyguards. It represents one of nature's examples of tool use in invertebrates, showing that even creatures without complex brains can learn to employ other organisms as defensive equipment in the competitive world of coral reefs and rocky shores. 27. The tiger shark has earned itself the rather unflattering but entirely accurate nickname, the garbage can of the sea, through its absolutely indiscriminate eating habits. These sharks will consume virtually anything they encounter, whether it's edible or not. According to NOAA Fisheries research, examinations of tiger shark stomach contents have revealed an astonishing array of items. License plates, tires, pieces of boats, aluminum cans, bags of trash, unopened cans of food, and even full suits of armor from ancient shipwrecks. Mixed in with this junk are the shark's actual prey: sea turtles, seabirds, other sharks, rays, fish, dolphins, and squid. Tiger sharks have powerful jaws and serrated teeth designed to crack through sea turtle shells, which means they can bite through almost anything that fits in their mouth. Their digestive systems are remarkably tolerant, capable of handling a wide variety of organic material, though the inorganic garbage they sometimes swallow often just sits in their stomachs indefinitely. This indiscriminate feeding makes tiger sharks both efficient scavengers that help clean up ocean debris and occasionally unfortunate victims of human pollution when they swallow plastic or other indigestible materials that can cause health problems or even death. 28. The sand dollar looks like a smooth, flat disc that beachcombers love to find washed up on shores, but most people don't realize they're holding the skeleton of what was once a living sea urchin. When alive, sand dollars are covered in thousands of tiny moving hairs called cilia that work together to help the creature burrow into sand and move food particles toward its mouth. According to Smithsonian Ocean Portal research, these cilia create coordinated waves of movement across the sand dollar's body, essentially pushing it through sand like a living Roomba. The distinctive 5-point pattern visible on a sand dollar's surface, looking like a flower or star, represents the animal's anatomy, with tube feet emerging from these petal patterns when alive. This pattern has inspired considerable mythology and symbolism, with various cultures calling sand dollars mermaid coins or coins of Atlantis. Christian tradition sometimes calls them holy ghost shells and interprets the 5-pointed pattern as representing the 5 wounds of Christ. But the actual sand dollar cares nothing for symbolism. It simply uses those thousands of tiny hairs to navigate life buried in sand, filter, feeding on tiny particles while hidden from predators beneath the seafloor. 29. The mantis shrimp possesses what scientists consider the most complex vision system of any creature on Earth. According to research from the University of Queensland, these colorful crustaceans have eyes that can move independently of each other, each eye capable of perceiving depth on its own, something human eyes cannot do individually. Each eye contains 16 types of photoreceptor cells, compared to the 3 types in human eyes. This allows mantis shrimp to detect not just visible light, but also ultraviolet wavelengths, infrared, and polarized light in ways humans cannot even imagine. They can see circular polarized light, which no other animal is known to perceive, and they can detect differences in light polarization that remain invisible to virtually every other creature. This extraordinary vision might help them recognize other mantis shrimp, identify prey, or communicate through light signals, though scientists are still working to understand all the implications. The mantis shrimp essentially sees a visual world far richer and more complex than anything humans experience, perceiving colors and light patterns that exist beyond the capability of our eyes to detect or our brains to process. It's vision on a completely different level, operating in dimensions we can barely understand. 30. The Portuguese man-o'-war looks like a single jellyfish floating on the ocean's surface, trailing long tentacles that can stretch over 100 feet behind its purple-blue sail. But it's not one creature. It's actually a colony of 4 different types of specialized organisms called zooids, all working together as a single functioning unit. According to National Geographic research, each type of zooid handles a specific job. Some form the floating sail and keep the colony at the surface. Others become the stinging tentacles that capture prey with venom powerful enough to kill fish instantly and cause excruciating pain to humans. Still others handle digestion, breaking down captured prey and distributing nutrients to the entire colony. A 4th type manages reproduction, ensuring the colony can spread and create new man-o'-war colonies. These zooids are so specialized that they cannot survive independently. Each type depends completely on the others for survival. The colony acts as one organism, but it's really 4 different types of creatures that evolved to sacrifice individual identity for collective success. It's cooperation on a cellular level, creating a predator that drifts across tropical and subtropical seas, fishing with venomous tentacles that hang like deadly streamers beneath its beautiful, balloon-like sail. 31. The giant oarfish holds the title of longest bony fish ever recorded, with confirmed specimens reaching 36 feet from head to tail, longer than a school bus. These silvery, ribbon-like creatures live in deep water and are rarely seen alive, usually only appearing when sick or dying individuals wash up on beaches. According to NOAA's Deep Sea program, the oarfish's bizarre appearance and rare surface sightings inspired centuries of sea serpent legends told by sailors worldwide. With its elongated, compressed body, bright red dorsal fin running the entire length of its back, and strange, undulating swimming motion, an oarfish glimpsed from a ship's deck would indeed look like some mythical serpent rising from the depths. Ancient mariners had no reference for such a creature and interpreted the sightings through the lens of mythology. The fish gets its name from its long, oar-shaped pelvic fins that trail from near its head, though it actually swims by rippling its long, dorsal fin in continuous waves while holding its body relatively straight. Oarfish feed on tiny plankton and small fish, using their lack of swim bladders to drift vertically through the water column. They remain mysterious. Most of what we know comes from dead specimens, rather than observations of living fish in their natural deep-sea habitat. 32. Crabs are famous for their distinctive sideways scuttle, but they're actually capable of walking in any direction they choose. According to Smithsonian Institution Anatomical Studies, the crab's sideways walk isn't a limitation. It's an efficiency choice based on how their legs are jointed. Each leg bends and articulates in ways that make lateral movement faster and more efficient than forward movement. When moving sideways, all 8 walking legs can move in coordinated rhythm, pushing and pulling in perfect sync to create rapid scuttling motion. If a crab tries to walk forward, the leg positioning becomes awkward, forcing some legs to pull while others push, creating slower, less coordinated movement. It's evolutionary engineering at work. Crabs developed body structures that optimized for quick escape from predators, and sideways motion provided the best solution. Some crabs can move forward when necessary, particularly when precision matters more than speed. But when danger threatens and they need maximum velocity, sideways remains their preferred direction. This anatomical adaptation has become so iconic that moving like a crab has entered human language as shorthand for sideways motion, even though the crab itself sees nothing unusual about its most efficient direction of travel. 33. Sea urchins possess remarkable regenerative abilities that allow them to rebuild damaged spines and even repair portions of their hard skeletal shell after injury. But their most extraordinary feature might be their longevity. According to research published in the Journal of Experimental Marine Biology and Ecology, sea urchins living in the cold waters off Alaska have been documented at over 200 years old, making them some of the longest-lived creatures in the ocean. Scientists determine age by measuring growth bands in urchin skeletal plates, similar to counting tree rings. These ancient urchins survive through slow metabolism and the cold water that reduces their energy needs. They spend 2 centuries slowly crawling across rocky sea floors, grazing on kelp and algae with their specialized chewing apparatus called Aristotle's lantern, 5 self-sharpening teeth arranged in a circular pattern. The same urchin might graze the same patch of reef for human lifetimes, watching the ocean change around it, outliving the fish, the seals, even the whales that swim overhead. Its patience and persistence embodied in a spiny sphere, living at a pace that makes human lifespans seem like brief flashes by comparison, demonstrating that sometimes survival favors the slow and steady. 34. Some jellyfish species possess an ability that sounds like science fiction. If you cut them in half, each piece can regenerate into a complete new jellyfish. According to research from Woods Hole Oceanographic Institution, this remarkable cloning ability stems from the jellyfish's relatively simple body plan and specialized cells that can transform into whatever tissue types are needed. When a jellyfish is divided, cells near the wound site receive chemical signals that trigger regeneration. These cells begin multiplying and differentiating, slowly rebuilding the missing portions of the body. Over days or weeks, depending on the species, 2 complete jellyfish emerge where one existed before. This isn't just healing, it's creating an entirely new organism from part of the old one. The ability serves jellyfish well in the open ocean, where collisions with predators, boats, or other obstacles might tear pieces from their soft bodies. Rather than dying from such injuries, many jellies simply regenerate, turning damage into an opportunity for reproduction. Some species can also reproduce this way intentionally, fragmenting themselves to create clones without needing to find a mate. It's asexual reproduction through division, allowing jellyfish populations to expand rapidly when conditions are favorable, turning one individual into many. 35. Every night, parrotfish engage in a behavior that seems almost paranoid, but is actually brilliant survival strategy. They create a transparent bubble of mucus that completely surrounds their body while they sleep. According to NOAA reef studies, this mucus cocoon takes about 30 minutes for the fish to secrete from special glands. The bubble serves as an organic odor shield, masking the parrotfish's scent from nocturnal predators that hunt primarily by smell, like moray eels. Without the mucus bubble, a sleeping parrotfish would be easy prey, its scent trail leading predators directly to its resting spot in the coral. Inside the mucus cocoon, the parrotfish becomes essentially odorless to predators swimming nearby in the dark. The bubble is delicate and permeable enough that water can flow through it for respiration, but thick enough to trap the chemical scents that would otherwise broadcast the fish's location. Come morning, the parrotfish breaks through its protective bubble and begins another day of grazing on algae-covered coral with its beak like teeth. The discarded mucus cocoon disintegrates or gets eaten by other reef creatures, recycled back into the ecosystem. It's a nightly ritual of protection, the parrotfish's personal security system against the dangers of sleeping exposed on a coral reef. 36. The dugong, a gentle marine mammal that grazes on seagrass in shallow coastal waters around Australia and the Indian Ocean, may have inspired one of humanity's most enduring myths, mermaids. According to Smithsonian Archives historical research, sailors spending months at sea catching glimpses of dugongs in dim light or at distance could have mistaken these creatures for something more humanoid. Dugongs have rounded heads, noticeable breasts when nursing, and a horizontal tail that might resemble a fishtail when viewed partially above water. They use their front flippers in ways that could appear arm-like, and they sometimes hold seagrass with these flippers while eating, creating a posture that might seem eerily human, like from afar. Their habit of surfacing to breathe, then submerging again, could create the impression of a creature that's part human and part fish. While modern viewers would never confuse a dugong with a human, sailors centuries ago, exhausted from long voyages, likely seeing the animals briefly and from considerable distance, might have their imaginations fill in details their eyes couldn't clearly see. The mermaid legend appears across many cultures in coastal regions where dugongs and their close relatives, manatees, live, suggesting these gentle marine mammals inspired tales of beautiful, mysterious creatures that were part woman and part fish. Ancient maritime folklore born from biological reality, viewed through the lens of human imagination and longing. 37. The blue-ringed octopus presents one of the ocean's most striking contrasts between size and danger. This tiny cephalopod typically measures no larger than a golf ball, small enough to sit comfortably in a human palm. But according to research from the Australian Institute of Marine Science, it carries enough tetrodotoxin venom to kill 26 adult humans within minutes. There is no antidote. The venom attacks the nervous system, causing paralysis that prevents breathing while the victim remains conscious throughout the ordeal, unable to move, unable to breathe, but fully aware. The octopus normally appears tan or brown, camouflaging against rocks and coral, but when threatened or hunting, brilliant blue rings suddenly appear across its skin as a warning display. Those rings aren't decorative, they're a clear message meaning stay away or die. The octopus doesn't waste venom, it only bites when provoked or handled. Unfortunately, their small size and beautiful appearance sometimes leads people to pick them up, not recognizing the danger until those blue rings flash their warning. The contrast between the creature's tiny, jewel-like appearance and its absolutely lethal venom makes it one of the ocean's most dangerous animals, proving that in nature, the prettiest packages sometimes contain the deadliest contents. 38. The weedy sea dragon, a close cousin of the leafy sea dragon, exhibits its own remarkable camouflage strategy, changing color to match patterns of seaweed and kelp in its environment. According to research from the South Australian Research and Development Institute, these fish can shift their coloration from reddish-brown to yellow-green to purple, depending on what provides the best concealment in their current location. Like seahorses, sea dragons have an unusual reproductive arrangement where males carry the fertilized eggs rather than females. The female deposits her eggs onto a specialized brood patch on the male's tail, where they attach and develop over several weeks. The male carries dozens of embryos, his tail swollen with eggs that develop protected beneath his care until tiny, fully formed sea dragons emerge. This role reversal continues throughout their reproductive life. Females produce the eggs, but males handle all the pregnancy and protection duties. The weedy sea dragon's combination of color-changing camouflage and unusual parental care makes it a particularly fascinating example of how evolution creates diverse solutions to survival and reproduction challenges. These strange and beautiful creatures drift through Australian coastal waters, perfectly adapted to their kelp forest homes in ways that continue to fascinate researchers and divers fortunate enough to spot them. 39. The glass squid has developed near-perfect transparency as its primary defense against predators in the open ocean's twilight zone. Most of its body is so clear you can see straight through it, making the squid nearly invisible in the water column. According to Scripps Institution of Oceanography Research, the squid fine-tunes this camouflage by adjusting its light organs, small bioluminescent spots on its body that can glow at varying intensities. When sunlight filters down from above, predators looking up would normally see the squid's silhouette against the brighter surface. To counter this, the glass squid uses its light organs to produce bioluminescence that exactly matches the intensity and color of downwelling sunlight, effectively erasing its shadow. This technique, called counter-illumination, makes the squid disappear from the perspective of predators hunting from below. The squid constantly adjusts its light output as it moves through different depths where sunlight intensity changes. It's like wearing an invisibility cloak that requires constant manual adjustment, but the effort pays off. In the open ocean, where there's nowhere to hide, transparency and strategic lighting become the difference between survival and becoming another creature's meal. The glass squid has mastered this delicate balance, turning its body into a living optical illusion. 40. The Japanese spider crab possesses the longest leg span of any arthropod on Earth, measuring up to 12 feet from claw tip to claw tip, roughly the height of a basketball hoop. According to documentation from Tokyo Sea Life Park, these crabs can weigh up to 40 pounds, with most of that weight in their long, spindly legs rather than their relatively small body. Those enormous legs serve important purposes beyond just creating an impressive appearance. They allow the crab to move across deep sea floors with minimal energy expenditure, essentially walking on stilts that keep its body elevated above the sediment. The crab lives at depths between 160 and 2,000 feet, where it scavenges along the seafloor for dead animals, shellfish, algae, and pretty much anything edible it encounters. But perhaps most remarkable is the Japanese spider crab's longevity. These creatures can live for more than a century, slowly crawling across underwater landscapes for human lifetimes, growing steadily larger throughout their extended lives. That combination of extreme size and extreme age makes them living bridges across generations. Individual crabs potentially older than any human alive today, still scuttling through the depths on legs that span distances humans would measure with yardsticks. 41. The cookie-cutter shark earns its name through a feeding strategy so unusual it sounds almost made up. This small shark, rarely exceeding 20 inches long, approaches much larger animals, whales, dolphins, large fish, even submarines, and attaches itself using specialized suction, cup-like lips that create a tight seal on the victim's skin. According to NOAA Fisheries research, once attached, the shark rotates its body while biting down with its razor-sharp teeth, twisting out a perfect circular plug of flesh. The resulting wound looks exactly like someone used a cookie cutter on the animal's skin, creating a perfectly round crater about 2 inches across. The shark swallows this plug of flesh and meat, then releases and swims away to find its next target. Many large marine mammals bear multiple cookie-cutter scars, evidence of past encounters with these small but effective parasitic predators. Even more remarkably, submarines and underwater equipment have returned to port, bearing circular gouges where cookie-cutter sharks apparently mistook metal hulls for whale skin. The Navy took these incidents seriously enough to study the problem, as the shark's teeth proved capable of damaging sensitive equipment. It's proof that size doesn't determine effectiveness. Sometimes a tiny predator with a specialized strategy can successfully hunt animals hundreds of times larger than itself. 42. Sea anemones wave their tentacles in ocean currents looking like colorful flowers, but they're actually carnivorous animals related to jellyfish and coral. According to NOAA coral reef ecology research, those beautiful tentacles are armed with thousands of specialized stinging cells called nematocysts that fire venomous barbs into any fish or shrimp that brushes against them. The venom paralyzes the prey almost instantly, and the tentacles guide the stunned victim toward the anemone's central mouth for consumption. Most fish instinctively avoid these dangerous flowers, but clownfish have developed a remarkable immunity through a special mucus coating on their skin that prevents the anemone's stinging cells from firing. This immunity allows clownfish to live among the tentacles safely, gaining protection from predators that won't risk entering the stinging forest. In return, the clownfish chases away butterfly fish and other species that feed on anemones, and its swimming movements help circulate water around the anemone's body. The clownfish even brings food scraps back to its host after feeding excursions. It's one of the ocean's most iconic symbiotic relationships, where immunity to venom transforms a deadly predator's tentacles into a safe home and partnership between two very different creatures. 43. Marine iguanas of the Galapagos Islands are the only lizards on Earth that have adapted to life in the ocean, diving beneath the waves to graze on underwater algae growing on rocks. According to research from the Charles Darwin Foundation, these remarkable reptiles can dive to depths of 30 feet and remain submerged for up to 45 minutes while feeding, though most dives last only 5 to 10 minutes. The iguana's bodies are specially adapted for this aquatic lifestyle. They have flattened tails for swimming, long claws for gripping slippery rocks in strong currents, and blunt noses perfect for scraping algae off underwater surfaces. But being cold-blooded reptiles diving into cold Pacific waters creates a problem. The marine iguana's body temperature drops during underwater feeding sessions, slowing their metabolism and movement. After emerging from the ocean, the iguanas bask on black volcanic rocks, absorbing heat from both the sun and the sun-warmed stone beneath them. They often lie piled atop each other in large groups, sharing warmth until their body temperature returns to normal. These odd creatures evolved their ocean-feeding lifestyle because terrestrial food was scarce in the Galapagos. forcing them to exploit the rich algae gardens growing underwater, a resource no other lizard had learned to access, creating an evolutionary niche that marine iguanas now dominate. 44. The sea hare, despite its name, is actually a large marine slug that can grow to over a foot long and weigh several pounds. According to research from the University of California, Santa Cruz, when threatened by predators, the sea hare releases a cloud of purple ink, similar to how squid deploy their defensive ink. But the sea hare's ink works differently. Instead of creating a visual smokescreen, it attacks the predator's sense of smell. The purple substance contains chemicals that overwhelm and confuse the predator's olfactory receptors, essentially flooding their nose with an avalanche of conflicting scent signals. Predatory fish rely heavily on their sense of smell to track prey, and the sea hare's ink essentially blinds them to the slug's scent trail. While the predator struggles to make sense of the chemical chaos, the sea hare makes its escape, crawling or swimming away from danger. The ink also tastes unpleasant, discouraging predators from continuing their attack even if they manage to bite down. Some sea hare species can release multiple ink clouds in succession if needed, creating waves of olfactory confusion. It's a defense mechanism perfectly calibrated to exploit predators' reliance on chemical senses, turning their primary hunting tool against them through sophisticated biological chemistry. 45. Sea spiders look like true spiders that somehow ended up underwater, but they're actually ancient arthropods from a completely different evolutionary lineage. According to Smithsonian Institution research, these strange creatures face a unique anatomical challenge. Their bodies are so thin and small that there's insufficient space inside to hold all their necessary organs. Evolution solved this problem in a bizarre way. Sea spiders store their digestive organs, reproductive organs, and sometimes even parts of their nervous system inside their legs. Each leg contains branches of the digestive tract, allowing the sea spider to process food throughout its entire body rather than in a centralized stomach. When they reproduce, eggs develop inside the legs as well, with males often carrying fertilized eggs on specialized leg appendages until they hatch. This distributed anatomy seems inefficient, but it works perfectly for creatures that evolved to have minimal body mass while maintaining long legs for walking across sea floors and climbing through coral and seaweed. Some sea spider species have leg spans over 2 feet, despite bodies smaller than a nickel. They feed by piercing soft-bodied prey with a proboscis and sucking out the internal fluids, then distributing that nutrition through legs that function as both limbs and living storage containers for their scattered organs. 46. The frilled shark appears to have swum straight out of prehistory. It looks nearly identical to fossils from 80 million years ago, earning it the nickname living fossil. According to research published in Marine Science Journal, this deep sea shark has remained essentially unchanged for tens of millions of years, suggesting its body plan reached such successful optimization for its environment that evolution found little to improve. The frilled shark possesses several primitive features that have disappeared in most modern sharks. 300 needle-like teeth arranged in 25 rows, an elongated eel-like body, and 6 pairs of gill slits with frilly edges that give the shark its name. Its jaws can unhinge dramatically, allowing it to swallow prey whole even when that prey is surprisingly large. The shark's mouth can open wide enough to consume fish over half its own body length. The frilled shark hunts in deep water, typically between 160 and 5,000 feet deep, where it feeds on squid, fish, and other sharks. Its flexible body allows it to strike like a snake, lunging forward and bending into positions that would be impossible for most sharks. Encounters with living frilled sharks are rare. They typically remain in deep water and are only occasionally caught in fishing nets or observed from deep-sea submersibles. Each sighting provides a glimpse into what ancient oceans might have looked like, a window into prehistoric seas that this unchanged predator has carried forward into the modern world. 47. The trumpetfish employs one of the reef's cleverest hunting strategies. It hovers vertically among coral branches or sea fans, its long, thin body perfectly mimicking the shape and color of the coral around it. According to research from the Smithsonian Tropical Research Institute, when small fish swim past, they often fail to recognize the perfectly camouflaged predator lurking vertically in what appears to be harmless coral. But the trumpetfish has an even more devious strategy called shadow hunting. It swims alongside larger, non-predatory fish like parrotfish or groupers, essentially using them as mobile camouflage. Prey fish see the large, familiar fish approaching and don't perceive any threat. They don't notice the trumpetfish hiding behind or alongside until it's too late. At the last second, the trumpetfish darts forward from behind its unwitting accomplice and sucks up the small fish through its long, tubular snout, which works like a powerful vacuum. The prey fish disappears into the trumpetfish's mouth so quickly that other fish nearby may not even realize an attack occurred. It's hunting through deception and misdirection, using both camouflage and the cover of innocent bystanders to get close enough to strike. The trumpetfish proves that on coral reefs, sometimes the best hunters are the ones you never see coming. 48. The zebra mantis shrimp engages in a form of combat that looks like something from an underwater martial arts tournament. According to research from the Marine Biological Laboratory, these colorful crustaceans perform ritual boxing matches with rivals of the same species, but with a fascinating twist, they follow rules. When two mantis shrimp dispute over territory or mates, they face each other and take turns striking, with each individual receiving a hit and then delivering one in response. This measured combat continues back and forth until one shrimp signals submission by backing away. What's remarkable is that these powerful creatures, which can break aquarium glass with their strikes, appear to deliberately hold back during these ritual fights. They're performing a test of endurance and willingness to fight rather than attempting to seriously injure each other. It's as if they've developed an understanding that actually hurting each other would be counterproductive to the species' survival. The zebra mantis shrimp that endures the most strikes, without retreating, wins the contest and the disputed resource. This behavior suggests a level of social complexity and restraint that many people wouldn't expect from a crustacean, showing that even creatures we consider simple have evolved sophisticated ways of resolving conflicts without unnecessary violence. 49. The chain cat shark possesses an ability that remained unknown until recently. It glows in the dark. According to research from the Florida Institute of Technology, this small shark uses biofluorescence to communicate in the dim waters along the Atlantic coast where it lives. Unlike bioluminescence, which produces its own light through chemical reactions, biofluorescence absorbs blue light from the environment and re-emits it as green, giving the shark an eerie glow visible to other animals that can see in those wavelengths. The chain cat shark's skin contains fluorescent compounds that create glowing patterns across its body, patterns that become especially prominent along the shark's distinctive chain, like markings that give it its name. Scientists believe these glowing patterns help the sharks recognize members of their own species in murky or deep water, where visual signals are difficult to perceive. The fluorescence may also play a role in mating, allowing sharks to identify potential partners and display their fitness. To human eyes viewing the sharks under normal light, they appear as simple gray-brown fish with chain-link patterns. But under blue light or in the shark's natural habitat, where blue wavelengths dominate, these fish transform into glowing creatures, broadcasting silent messages through bioluminescent patterns invisible to most other creatures in the sea. 50. The spiny lobster lacks the large claws that make their Maine lobster cousins famous, but they've evolved an entirely different defense mechanism, the ability to scream underwater. According to research published in Marine Ecology Progress series, Spiny, lobsters produce a loud, rasping squeak or squeal by rubbing a specialized part of their antennae against a smooth area of their shell, creating friction that generates sound. This stridulation, the same mechanism crickets use to chirp, can be surprisingly loud underwater, functioning as a warning signal to potential predators. The sound tells predators that the lobster is aware of their presence and ready to defend itself, potentially causing the predator to choose an easier, quieter target instead. The noise can also alert other lobsters to danger, creating a chain of warnings through a reef or rocky area. Spiny lobsters also use these sounds for communication with each other, possibly to establish territory or attract mates. It's remarkable to think that a creature without vocal cords, living in an environment where sound travels differently than in air, has evolved a mechanical sound production system that effectively serves as an underwater voice. The rasping squeak of a spiny lobster becomes one more sound in the complex acoustic environment of the reef, where many creatures communicate through noises humans rarely hear. And there you have it. 50 fascinating facts about ocean creatures that reveal just how extraordinary life beneath the waves truly is. Each fact reveals how evolution finds countless solutions to the challenges of survival, creating a diversity of life that challenges imagination and expands our understanding of what's possible. If you enjoyed this journey through the ocean's remarkable inhabitants, please give this video a like and subscribe to the channel for more fact-filled explorations. Drop a comment below, sharing which facts surprised you most. Thanks so much for spending this time exploring the ocean's wonders with me. Until next time,